Okay, we're going to start going over part 2 of the January 2018 geometry exam. We're starting off with problem number 25, and there are 7 problems on part 2, and each one is worth 2 points. So you want to make sure and do your work, because you can forget one simple thing and you lose a point out of the 2. They don't take away half points on the exam, so be careful. So looking here, it says parallelogram. So parallelogram ABCD with diagonal AC is drawn. So we have a parallelogram here, parallelogram. So that anytime you see vocabulary like that, you should start thinking about, what do I know when I have a parallelogram, right? What do I know? So I have written down 5 properties that are true of every parallelogram. So I want you to write these down, okay? If you are in my class and you want credit for doing this, you need to write these down, okay? Every parallelogram has these 5 properties. All right, now, all of them might not be helpful for us in this proof, but these are things you should know. So write those down. Take a second, write those down, and you can pause the video. All right, what we're trying to prove is that triangle ABC is congruent to triangle CDA. Right? Okay, so now, remember, there are different ways you can prove triangles congruent. You can use side, side, side. You can use side, angle, side. You could use angle, side, angle. What's the other one? Angle, angle, side, or hypotenuse, leg. All right. Now, if we look at our 5 properties, the ones that I'm looking at that are going to help us out are, first off, number 2, opposite sides being congruent. So we know this is a parallelogram, and based on the information, we can assume that this is a parallelogram. We know that CD and AB are the same. We also know that AD and CB are the same, all right? And then we know that they share AC by the reflexive property. So right there, we could use side, side, side. All right, we could go in other directions, but that's the easiest way that I see. Okay, so now let's go ahead and write this up. All right, so here's what I started with. I said, since it is a parallelogram, the opposite sides are congruent. Therefore, side AD, and we mark that, is congruent to side CB. Also, side AB is congruent to side CD, and we mark those things, right? And that's all based on the fact that it is a parallelogram, all right? And also, side AC is congruent to side CA by the reflexive property. Both triangles share the side. Now, you might be wondering, why did I say AC and CA? Well, that's a small thing, but if you were to place the blue triangle on top of the red triangle here, you would notice that the A point of C, or the A vertice, I'm sorry, the A vertice of this blue triangle actually would land on top of C. So if you can imagine that, actually, so that's why I have AC is congruent to CA, because technically that would be the proper way to say it. Okay, I don't think they'd mark off if you said AC is congruent to AC. I'm not sure, but that's why I wrote it that way. All right, so we have, we can finish up. Therefore, triangle ABC is congruent to triangle CDA by side, side, side. All right, side, side, side. Okay. Okay, now we're going to look at problem number 26. which is a construction. And it's a little bit different than usual because they actually give you a circle to start with a diameter. But it says the diagram below shows circle O with diameter AB. Using a compass and a straight edge, construct a square that is inscribed. Inscribed means inside, and it has to be touching the circle. All right, so it's inside circle O and leave all construction marks. Okay, so here are the properties of a square that are actually used in this construction. All right, so I want you to write these down. The diagonals, the fact that the diagonals of a square are congruent, and that the diagonals are perpendicular and bisect each other at right angles. Okay, so go ahead and write that down. Now, if you have a compass and a straight edge, you can follow along with what I'm doing. Okay, I've seen this question before to where they just tell you to do a square inscribed in a circle, and you have to draw the circle, you have to draw the diameter, and then go from there. Here, they give you the circle with the diameters. They actually did the first couple of steps for you. So let's go ahead and do the rest. All right. We're going to do the perpendicular bisector of the diameter. So perpendicular bisector, I'm going to put my point, put the point of my compass on A, stretch it out more than halfway, and I'm going to draw a circle here. All right. You don't need to draw the entire circle, but I'm doing it just for the purposes of this construction. All right, I'm going to draw another circle centered at B. Now I'm going to draw the perpendicular bisector. And I'm really only concerned about where it hits the circle. And if we do it correctly, it should go right through the center point. All right, so now we have 4 points on the circle. And let's mark those 4 points. So we have 1, 2, 3, 4. All right? So what you actually have here, you actually have the diagonals of a square. And the reason why you know they're congruent is because they are both diameters of the circle. So we know they're congruent. Also, we know that they are perpendicular to each other and that these are right angles because what we did was the perpendicular bisector. By definition, that's going to create 2 line segments that are perpendicular and cross at right angles. So if we now just simply use our straight edge, which I don't need a straight edge with this program that I'm using, this this smart notebook, but you'd want to use a ruler, connect these 4 points, and there you go. You now have a square that is inscribed in a circle. Okay? So that's all you had to do. Pretty easy 2 points if you remember how to do that. All right, let's look at number 27. It says, given right triangle ABC with a right angle at C, if sine of A increases, does the cosine of B increase or decrease, and explain why? Okay, now, couple things. They say it's a right triangle with right angle at C. So if you wanted to draw a right triangle, that might be helpful to help you picture it. So I could just draw a right triangle. Right triangle here. And I know that this is C. Really doesn't matter what you label the other ones. What's important is you realize that if C is a right angle, which means it measures 90 degrees, that means that A and B have to add up to 90. I mean, we don't know what their angles are or what the measures are, but they have to be 90. We don't know if it's 50 and 40 or 30 and 60 or 70 and 20, but they have to add up to 90, and that's important. All right, let's write this first note down. Okay, so here's the first note. This isn't the answer to our question, but it is a note there. So if 2 angles are complementary and add up to 90 degrees, then the value of sine and cosine are equal. So in other words, when A plus B equals 90, so when the angles equal 90, then the sine of A is equal to the cosine of B. Okay? and I'm going to get out the calculator just to show you a little bit about this, or just, make it a little clearer. All right? So if I look at my calculator here, and if you pick any angles that add up to 90, so let's just say 30 and 60. So if I take the sine of 60 and the cosine of 30, right, they're equal. If I take the sine of 50 and the cosine of 40, they're equal. Now notice, those angles add up to 90. So when the angles add up to 90, the sine and cosine of those two angles are going to be equal. Right, so now let's go back to our question here. It says, if sine A increases, does cosine B increase or decrease? Okay, well, think about this. If they're going to be equal, all right, if sine of A is going to be equal to cosine of B, and we know that because they have to add up to 90, all right, then that means as sine A increases, cosine B is going to be the same value, so it's going to increase right along with it. Okay? It's going to increase right along with it. So let's write something down. Let's explain. When it says explain, you need to actually put words, write a paragraph. You need to actually explain your thinking, your reasoning. So I have this here. If angle C is a right angle, then the other angles, angle A and B, must be complementary and add up to 90. Use the word complementary. That's a nice little vocabulary word to throw in. All right. Therefore, sine of A will always be equal to the cosine of B. So if two angles are complementary, again, what we highlighted right here, when A and B equal 90, A plus B equals 90, sine of A is equal to the cosine of B. All right. So based on that, as sine A increases, cosine B will also increase and be the exact same value. Okay? So that's the answer to that question. All right? So that's it for this video. We'll go over to the next ones, or the next couple, next time.